When the net force acting on a system equals 0, the system is said to be in a state of equilibrium or balance. This presentation will teach you how to tell whether a system of 3 or more forces could be arranged to create a state of equilibrium. When the net force on a system equals 0, the system is said to be in a state of equilibrium or balance. In the picture shown above, the 5 Newton west force is balanced by the 5 Newton east force, and the resultant or net force equals 0, and this system is in a state of equilibrium. Newton's second law tells us that an object with a net force equal to 0 would have no acceleration. It means the object could be at rest or it could be moving with constant velocity, which means if it were moving, it wouldn't speed up, slow down, or change direction. When an object has 3 or more forces on it, it is not immediately obvious whether the forces could actually be arranged to produce a state of equilibrium or balance. For example, could the forces 4 newtons and 6 newtons ever be arranged to balance out a force of 8 newtons? I'll give you a hint. If 4 and 6 newtons could balance 8 newtons, what would the resultant have to be? When we add and subtract these two forces, we find these forces could create resultants that are between 10 newtons, 6 plus 4, and 2 newtons, 6 minus 4. Since 8 newtons is within the range of the possible resultants, these forces can be in a state of equilibrium. 3 forces can be in a state of equilibrium if one of the forces is within the range of the resultants of the other 2. 8 newtons is within the range of 10 newtons to 2 newtons, and you find this by adding and subtracting the forces. Let's try another one. Could the angles of these forces ever be arranged to produce a state of equilibrium? The first step to finding out if these forces could be in a state of equilibrium is to pick any 2 forces and find the range of possible resultants. When we add and subtract the forces, we find that the range of possible resultants is from 9 newtons to 1 newtons. Since 10 newtons is not within the range of possible resultants of 4 newtons and 5 newtons, these 3 forces could never be arranged to produce a state of equilibrium. Which diagram below represents a box in equilibrium? Only in choice 2 are all the forces balanced. The answer is choice 2. Only choice 2 is in a state of equilibrium because the forces pointed towards the left are balanced by the forces pointing towards the right, and the forces going up are completely balanced by the forces going down. Which boxes are in a state of equilibrium? 3 boxes are in a state of equilibrium, and they're in a state of equilibrium because the forces to the left are balanced out by the forces on the right, and the forces up are balanced by the forces down. In this presentation, you learned that a system is in a state of equilibrium if the net force equals 0. You learned that when the net force on a system is 0, its acceleration is 0. You learned that 3 forces can be in a state of equilibrium if one of the forces falls within the range of possible resultants of the other 2. This is the end of my presentation on equilibrium.